So in this shape, you can see that this shape lies flat in a plane, right?
Yeah.
Yeah.
And if we drew some lines,
Yeah.
So is this shape only recently discovered?
Well, you know what? I don't know the answer to that, actually. That's a very good question. Henry Segerman made this shape out of 3D printing. I don't know if he discovered the shape or not. But it is true that in reasonably recently, in terms of math,
Like 100 years?
yeah, that people did figure out a way, and I'll show you some pictures of a different way to embed the torus in 3 dimensions. So what's neat about this shape is it has the geometry of the plane. In fact, if you had another copy of this, I could put, you see how this would fit right in there if I had another copy of it?
Yeah.
This bend would just match that bend, and I could actually tile the plane with this shape. I could put one right on top of each other. I got straight lines on the top and bottom. I got this equal bends. I could just line them up and then tile the whole plane. So this looks like it has the same. This shape looks like it has the same geometry as the plane.
Interesting.
And when I fold it up, I probably shouldn't be trying to do this on camera, but let's see if I can. When I fold it up, you see the interesting twists
Yeah.
that cause. That one good.
There.
You got it?
Yeah.
And it looks like, and it might not be perfect because we do have to worry about something about some corners and things like that. That's okay for now. It looks like we have straight lines. So if I had, when it was unfolded, I would have a straight line going up from the squares into the triangle. It's still all straight.
Yeah.
So it looks like the straight lines got preserved somehow. And that's actually pretty neat.
It's weird.
Yeah, so this is perhaps a little bit better representation of a torus compared to a bagel.
Bagel.
A little bit better. What are some things that you notice are different?
Well, you don't have a curved top anymore. It doesn't curve down naturally. It just comes up and slopes.
Okay, that's one interesting
And
difference.
here you don't. It doesn't look like you have a circle in here. You have like 1, 2, 3, 4, 5, 6, 7, 8. I think you have a decagon, maybe.
Okay, yeah. But could you imagine
If you did this with like thousands of lines.
making more and more and it would sort of look like a circle?
Yeah, and same for the outside, I guess.
Is there anything else that you notice in here that's a little bit different than the bagel?
So, the bagel, it kind of slopes down and then meets in one place and then slopes back up to it slopes down and then slopes back like a cliff,
Okay.
and then it goes. Oh, the bagel, it slopes down and then only does it a little at the bottom.
Okay.
It doesn't meet at one place.
You don't have any curves here.
Yeah, you don't
It's
have
all
any
just
curves.
lines.
It's all just lines. The thing that surprises me about this shape is this shape looks twisty to me. On the bagel, I can go around in a circle just right here.
Yeah.
But if I start here and I try to go down around in a circle, I don't go down around in a circle. Where do I go if I start at this point? Right here.
You go like down. Would you go on the
Yeah, I
side?
go this way. So this shape seems like it's a little bit more twisted.
Huh.
It's a little more twisty
Yeah.
than the bagel, which is interesting.
Yeah.
So you have to incorporate some sort of twists to make this what's called a flat torus.
Yeah.
All right, so this is actually related to some other shapes as well, by the way. And you said something this morning in your investigation of this shape that actually is really interesting. You asked if this was really a four-dimensional shape. And it is. A torus is actually a four-dimensional shape.
This is a 3D representation of the torus.
Right. This is a 3D representation of the torus. This is a 3D representation of the torus. And people weren't sure if you could get a good 3D representation of the torus, but a torus is really a four-dimensional shape. And that's really how the angles get preserved and the geometry gets preserved. We're going to look at two other shapes related to the torus right now. Okay?
Okay.
All right.